Today, for science, we're going to start on page 50. All right, we've been talking about the states of matter. Okay, the definition for a state of matter is material made up of molecules that has weight and takes up space. We learned that a minor molecule is a tiny particle of matter. Can you see them with your eye?
No.
No, you can only see them with a microscope. And then different matter would have different properties depending on whether it was
Solid, liquid,
or
and
gas. What did we learn about those solids?
They're packed tightly together.
Yes, the molecules in a solid are packed tightly together. That's why they are so hard. What did we learn about liquids?
The molecules are loose.
Yes, they're loose and they can do what?
Flow.
They flow, very good. They can flow, just like water flows. If you pour it out of a cup, it just flows right out of the cup. So the molecules of liquid can flow. Okay. I'll get that back to you later, okay? All right, today I want you to look at page 50 and we're going to talk about the gases, all right? There is a special state of matter that you cannot always see. The air you breathe is filled with this kind of matter. The air is made of gases such as oxygen, carbon dioxide, and nitrogen. Gases can fill up space but cannot be poured out like liquid. Gases can escape the area they are contained in very easily. This is because gas molecules have too much energy and move too quickly to stay together. They are only weakly attracted to each other. Though you may not see them, all gases have weight. Some gases are heavier or lighter than others. All right, so look straight across to their side where you see that bunch of balloons. Have you ever played with a helium balloon at a birthday party? The helium in the balloon was lighter than the gases in the air around it. That is why the helium balloons seem to defy gravity and float up into the air. All right? So in the air, right now, we have a mixture of gases. It is not just oxygen in the air we breathe. There are other gases in it too, okay? We're breathing oxygen, and when we breathe out the carbon dioxide because we don't need that gas, all right? There's nitrogen in the air. There's different gases in the air. We would not want it to be pure oxygen because pure oxygen is very flammable. If this air in this room was pure oxygen and we lit a match, this whole room would explode. So pure oxygen, God knew what he was doing when he made our atmosphere and the gases in the atmosphere. Now, talking about another gas, helium. You put that in a balloon, helium is lighter than the normal air in a room, so that is why that helium balloon will float up, okay? Now, I have some balloons here because we said that matter takes up space and has weight, right? Well, we think of air as not weighing that much, okay? So we're just going to prove, so I don't know if I may have to move this over a little bit. And I need, Riley, I'm going to let you do it, but you can't get in the way of the camera. The camera cannot see you because otherwise it won't. So let me get set up real quick. Can she see it now? Yes, she can. All right, I'm going to have you come over here so that she can't see you, and you're going to pop this when I tell you to. I just want to get it settled first. Yeah, she'll get ready for it. It's going on making noise. So, see, I'm going to balance these on. I just want to make sure it's right in the middle. Now, could I blow these up? Could I blow these up perfectly right?
No.
Not with my mouth, okay? A scientist could have. Right now, they just keep going back and forth between the two, don't they? So I need to find a place where I can have it just be settled. All right, it seems to be settling down now. Really? Well, it was. All right. You ready? Just poke it, quick. You gotta poke it. I thought I picked it. No, you can't push on it because then that will not work. Alright, try this.
It's just deflating.
Yeah, it is. She did poke it. She did poke poke it and it's slowly deflating. It was supposed to pop so that it was dramatic,
Yeah.
but it's not being dramatic, it's slowly deflating. Alright, now watch what's happening. Guys, look. What is happening to the yellow balloon?
The yellow balloon is heavier, so it's
Yes,
going
the
to the
yellow
one
balloon is
side.
heavier because the blue side is losing its air, it's losing the gases inside. So gradually, as the blue balloon gets smaller and smaller, the yellow balloon just gets heavier and heavier, okay? So even though she didn't pop it fast and it wasn't dramatic, typically if it pops very fast, then this side goes really fast. But because she popped it, but it didn't pop good, it just got a hole in it, it very slowly made that one sink in. Now, we were talking from our untie the balloon thing, we were talking about. Thank you. Alright, so we were talking from untie balloon, we were talking about untying balloon and spelling, right? So if we were to untie this balloon, what would happen to the gas?
It would be
Yes, so the air would go rushing out, right?
But don't.
Alright, so I'm not gonna poke it with a pen. Alright, turn to page 52, we have one more page to read. Alright, so this green box would be something important for a quiz or a task. Everybody see that green box where it says something to remember?
Yes, ma'am.
So anytime you see a something to remember, that is something important. So let's read about solids. States of matter, solids. Matter is able to keep its shape. So if it's a solid, it can keep its shape. Alright? Liquids. Matter is able to flow and spread out to fill the shape of a container. And gases? Matter is able to fill up space, but can easily escape. And it is not easy to untie a balloon.